Assalamualaikum warahmatullahi wabarakatuh. Today our group will present about application of mechanics in volleyball sports. So firstly, I will introduce myself. My name is Muhammad Ani Hazri bin Johari with matrix number 2022-856-924.
Hi, my name is Anur Najla binti Karun Nizam with matrix number 2022-625-484. Introduction. Newton's laws of motion are the statements describing the relations between the forces acting on the body and the motions of the body. Here are Newton's three laws of motion. The first one is first law, which is law of inertia. This refers to an object is at rest will remains at rest, and an object in motion will continue to move with a constant velocity in a straight line unless acted upon by an external force. For example, when the driver suddenly brake the car from hit the traffic light, the driver tends to move slightly forward. This means we can say that a static body will remain static unless it is affected by an external forces.
Now let's talk about Newton's second law of motion. Newton's second law of motion states that the force applied is equals to mass of the object multiplied with its acceleration. Newton's second law also can be related to projectile motion that we are going to talk about in this video. Projectile motion often occur in volleyball sports since the ball trajectory is in projectile motion. For example, when someone is serving the ball to the opponent's side, the ball is in projectile motion. Or we can use another example like spiking. When the player spike the ball sometimes can move in projectile motion or in a straight line motion.
The last one is third law, which is law of action-reaction. For every action, there is an equal and opposite reaction. When one object applies a force of equal magnitude in the opposite direction. For example, a bottle with a weight of 10 Newton downwards will be static because there is also a reaction force 10 Newton upwards.
Now, let's watch some video and answer some questions. First problem. Kageyama throw the ball at height 1.8 meters from the ground. What is the maximum point of the ball if the initial velocity of the ball is 9.5 meters per second? Now, let's go for the solution of the first problem. First of all, we can see that Kageyama throw the ball, or in a volleyball terms, we call it set to the spiker with a projectile motion. The ball reached its maximum point at this point. Now, to calculate the maximum point, the velocity when it reached its maximum point is 0. So, from the question, we know that Kageyama throw the ball with initial velocity 9.5 meter per second. So, by using v square equals to u square minus 2gs, where the v is 0 and the u is 9.5 meter per second and the g is 9.81 meter per second square, we can get the value of s, which is the displacement of the ball from its initial position, is 4.6 meter. The displacement of the ball from the ground is 4.6 meter plus 1.8 meter equals to 6.4 meter.
Second problem. A ball pushed to the opponent's side just right above the net at 5.2 meters per second takes 0.71 to hit the ground. Calculate the height of the net and the distance from net to where the ball landed. This is the solution for the second problem. For the height of the net, we need to find the vertical axis. Based on the motion of the ball, we can use S is equal to ut plus at squared over 2 as the formula. The initial velocity for the ball is 0 and given from the question, t is equal to 0.17 seconds. Acceleration is equal to 9.81 meter per second square. Substitute the v, t and a into the formula. Then we will get S is equal to 0 times with 0.71 plus 9.81 times with 0.71 square divided by 2. The final answer is 3.43. So, the height of the net is 3.43 meter. Then, we need to use horizontal axis to find the distance from net where the ball landed. Given from the question, initial velocity is equal to 5.2 meter per second. The ball moving with uniform velocity, thus there is no acceleration occur in the ball motion. So, we will use the formula S equal to ut plus at square over 2. So, we will get 5.2 times with 0.71 plus 0 times with 0.71 divided by 2. Then we will get the final answer is equal to 3.692 meter. So, the distance from net to where the ball landed is 3.692 meter.
Now for the third problem is Yamaguchi serves the ball to the opponent side with 8.9 meter per second. The ball is slowing down due to air resistance and decelerate with 0.125 meter per second square. If the length of the court is 18 meter and the final velocity of the ball before it touches the ground is 8.65 meter per second, will the serve going in or out of the court? Now let's go for the solution. So to solve this problem, we just need to consider about the horizontal motion. From the question, we know that the initial velocity is 8.9 meter per second. Then by using the formula v square equals to u square plus 2as, we can consider that the a is negative 0.125 meter per second square. We also know the final velocity is 8.65 meter per second. By substitute the value of u, v and a into the equation, to answer the question, will the serve going in or out, we must know that if the s is less than 18, the ball is going in, but if the s is greater than 18, so the ball is going out. By solving the equation, we get s is equals to 17.55 meter. So the ball is going in.
In summary, we can conclude that volleyball can be related to the second law. This helps us to understand what is projectile motion and how it can be applied to Newton's laws. Overall, doing this group project helps us acknowledge and know how to apply the calculation in everyday life to predict the motion of an object. Here is the reference that we use in our video. That's all from us. Thank you.